Okay, so today I'll be talking about creating XR collaborative spaces with RMIT and VECTR. First, of course, an overview. What is RMIT? RMIT stands for the Rapid Model Import Tool. It's essentially a CAD preparation, optimization application. So all that to say, optimizing models can be difficult, and there's not a lot of good tools that really hit all the use cases because everybody has different scenarios. So what we tried to make was a CAD importing tool that can take in many different file formats and then apply mostly automated operations that tend to be common when dealing with 3D meshes. Especially working in engineering aerospace, we tend to have really, really large file sizes and really complex models that can be hard to use in other domains, such as if you're doing a type of XR, interactivity, games and stuff like that. So some of the key features here is managing hierarchies. That tends to be depending on the model you get, you can have very in-depth hierarchies with a lot of layers. Grouping can sometimes be difficult, so we have model grouping centering. We have the capability to remove hidden objects that are not visible or even internal. Say there's a lot of pieces inside a model and those things aren't quite important. We give the opportunity to remove all those with a single button click. So a lot of this is mostly having like mostly autonomous actions or kind of semi-autonomous actions where you can kind of visualize the model within a 3D space. Our application is Blender, and then that way you can apply different actions to the model to try to prep it for whatever use case is. We also allow you to merge and split different mesh groups. Material cleanup. I've seen a lot of models come out of engineering applications that have tons of material definitions and a lot of copying of the same material type. So say you have a smooth metal. Well, that model may come in with 100 different smooth metal materials because the incoming program that you're exporting your model to may not know how to translate that or deal with instancing of materials instead of having a ton of copies, essentially. Then there's also small component removal. We allow you to kind of zone in on small pieces. Say there's a model that has a lot of rivets or washers or screws, and that's not really important for whatever type of visualization you're using. You can zone in on those objects and remove them in a single button click with a little bit of parameter tweaking. And then, of course, number one is always decimation. And what is decimation? Decimation is essentially taking the geometry that makes up the model and simplifying that. So say for instance, there's a face, this is considered a face, and is comprised of two triangles. That's a very clean face. But there's a lot of times when these may not be so clean. They may have a lot of what's called tessellation, which means it will divide those triangles into smaller triangles. And decimation kind of runs that backwards. It'll see that they say, hey, well, this doesn't need 10 triangles on a singular face. Let me simplify that and just give you two. Most models in most applications, even if they're a kind of like a square, they'll break into triangles. And that's how most geometry is kind of comprised of. Looks like I put small component twice, but that's okay. So I'm just going to give an overview of what our software looks like. This is what's considered our launcher window. You have a lot of options here. You can either run it headless, which means it'll run as a process in the background and you don't have to worry. I say, hey, I want to turn this model from this file format to that file format. Cool, run in the background. I don't worry about it. Exports it and you have your model. Say you want to do certain actions while that runs in the background. You have the ability to do so. Remove those hidden objects, separate objects, merge materials, linking them. You can do all that in the background if you wish. If you would like more of a guided type of setup, you can then run that non-headless and have this control window that appears. This control window will show up in the Blender interface along with the model, and then you can tweak these values and kind of hit those targets that you're looking for. Say you have a particular poly count, which means that the density of the model, you want it to be within a certain range so that your file size isn't too large. You can do that, and you can kind of zone in on those areas that you would like. So there's a lot of different tooling in here, and we're continuously extending this based on what we see to tend to be the most time-consuming tasks that modelers tend to go through. And since we're mostly engineers, We're not all 3D modelers. So this tool essentially brings a tool set to engineers without having to learn how to 3D model, because that's a whole craft in itself when it comes to creating really good 3D assets that are clean and easy to use. So the short of it is, what is RMIT? RMIT is a rapid model import tool and allows you to get a pretty good result with minimal effort, so that way you can focus on the important things. Just a little bit about the architecture. We'll take the file sources, they'll import. We do use what's called Datasmith. Datasmith is a pretty powerful importer that Unreal uses. We essentially utilize that engine in the background to expand our file types. It's really hard creating file parsers for different file types that continuously change. So we let Datasmith handle the heavy lifting when Blender cannot. So we'll import it. You know, people typically decimate, use the different cleanup functions, and then export that to whatever type of repository or the next engine that they're going to be utilizing these assets in. So an example of use, this was from the Astro Materials Lab. They were trying to bring down the file size of some of these rocks that they had. So this is a full resolution example. You're looking at 30 million triangles. That's a very dense model. It's going to be hard to utilize, especially in XR instances where you're worrying about frames per second, and those draw calls that are coming from the engine are going to be quite costly the more geometry you're dealing with. So this was a free application that the user tried to use to bring that poly count down, but you can see that there's a lot of loss of fidelity within the texture and the object itself. And then this was the result with RMIT, where you can see that we went from 30 million triangles down to 250,000 triangles. So it's an 83% reduction in mesh, but we haven't lost any of that fidelity. The model still looks very good. You really can't see any degradation in quality. So that's kind of the goal that we aim for, is to keep that fidelity while reducing down that file size, so that way it doesn't bog down the next environment that these models go into. And then we've an example of RMIT in use, and another product that we've kind of married together. We have a product called VECTR2. It's a collaborative VR sandbox. This was originally called VECTR, just VECTR1, and it was used to create like outreach instances. So we had like a KSC flyover and a couple like other public outreach type of instances, and we rebuilt this from the ground up. So that way we can have a little bit more versatility in creating these instances. Instead of having just like a one-off VR application, we created a sandbox, and that sandbox essentially contains a bunch of tools that users can go and then create their own instances and on their own levels, or outreach or training, whatever they need to make. So kind of bringing from RMIT that rapid model importing, now we're trying to rapidly create environments that use those models. Some of the key features in VECTR2 include multi-user environments. You have the option to go public or private, so that way you can have a little bit more security. Different navigation types. People in VR tend to like one navigation style over another. So we allow several options. Locomotion is the normal one that everyone typically knows, is you just move around, you move the sticks, and you kind of slide around. We also allow flight and teleport. Some of the main navigation types you'll see in VR applications: object manipulation, annotation. We allow some measurement tooling, runtime model loading using RMIT, and then a desktop mode for, say, you have a multi-user environment, maybe someone doesn't have a VR device. We allow them to come in a desktop mode. Granted, those capabilities would be limited because you don't have all the VR controls in your interactivity, but you'll still be able to participate. And then the architecture for this, you can see where we kind of took RMIT and then fed that into our VECTR project. And then we'll create VECTR instances from there. So rapid model importing, rapid environments, so that way you can create different mocks or demos or outreach instances without having to build things from the ground up or spend too much time on laborious tasks. So this is what our user lobby looks like. You can see that we have a little tutorial playing in the background that goes over the different options: setting up your profiles, joining rooms, creating your own rooms, adjusting your settings, and then your desktop and your VR mode. And then runtime loading. So we integrated RMIT into the user interface for Vector, and it allows you to look for your objects, load them into runtime, and then what that allows is as you go into these rooms, now those assets became available to spawn, so you can put them in the scene at runtime without having to do the pre-work of setting up the models or packages or creating the levels. You can just load those models while you're inside of Vector 2. So then room joining, say there's a room available, it would show up in that prompt. Or if you need to create a room, you can hit agree, and then there's a couple options here where you can go and create different rooms. And then we have different scenes. So we have a high bay, we have a clean room, we have a couple of different instances. And this being a sandbox, we allow users to create their own rooms. And this has the ability to create additional rooms and environments and then have those loaded in. And then the users can go into that type of environment. So, like I said, multi-user environments. This is one of our avatars. This is one of our little robot astronauts. You can see a couple models in the background that have been spawned in. There are different movement options. So flight and teleport are shown here. You can see with this side, we have kind of like a central point, and based on how you hold the trigger and move that away from the central point, you'll have your flight controls. We found this to be very intuitive and easy to pick up. You essentially just hold the wand where you need to. That's your starting point. And then you just offset from that position, and you can fly anywhere you want like a joystick. And then, of course, on the right side, you'll see the very traditional teleportation that you'll see in many other VR applications. So you can do that instantaneous movement into place. Asset loading. As I was saying earlier, you can use RMIT to load in different assets of different file types, and then bring that into the scene to be interacted with in a multi-user environment. This model will show in all users' UI, and then in the background we have a billboard. So say if there's particular data that comes with the models, that will be shown in the background. So that way everyone can see the different specifications or metadata that come along with the objects. Measurement, we created a measurement tool here. It has freehand mode, which means you can move multi-directional and take it. But say you want to move within a constraint of a specific axis, X, Y, Z, you can lock it into that axis and then take those measurements. There's actual little LED screens on the measurement tool that show the meters, and then your options you can change between imperial and metric. We also have annotation. We made some nifty little pencils, so that way you can draw in space and create different annotations. Of course, we allow you to flip the pencil around and then, of course, erase those annotations if you don't want them. This is our system menu. When you're in an environment, we give you a system menu. You can change the host. You can save the room for later revisiting, and then you can change between different options. Like I said, with the annotation tool, between metric and imperial, and then you can change your turning. Say you don't want to do the gradual rotation, we allow snap turning at certain degrees, which is another common feature for movement in many VR applications. So vector releases. Vector 1 had a couple instances. We had our Kennedy Space Center flyover and our Science Rex outreach. So essentially, we had created 2 instances for outreach, and we kind of rebuilt the system twice. And then we realized, well, why don't we create a sandbox where when people request these type of instances, we don't have to start over. We can take our current tool set, we can just generate a new level or environment, and then load that into the, have that be loaded into the application. So that way you retain all your tool sets, you retain all your hard work, and then you essentially just load into a different level. And we also, not only for us to create that much more quicker, we also allow users to create their own rooms so they can load in their own assets and create their own environments. And so what does Vector really solve? Training environments, outreach is a big one for us. That's kind of where the revising of Vector came from primarily. But of course, there's other places that this can be used. Our main thing was to be able to rapidly create new environment instances based on customer request, and that's VECTR's primary goal. But of course, it being a sandbox with a lot of tooling, you can change it up to whatever use case is. And that is my presentation. At this time, that's really all I have. Are there any questions?
Hey, Jose, this is Adam Fagan from Johns Hopkins. Question, is your RMIT application the same that's used at Goddard?
It depends on what team, because I know it is used at Goddard, and there's a good chance that it is.
Okay. Do you know if it's using like the Blender APIs or what it's written in, and is it using Python or?
Yeah, it's Python. It's all Python scripts built against Blender. Essentially, it is Blender, and it's using the BPY library, which is Blender's Python library, and that's how it utilizes that.
Okay. And does it have a batch mode where you can process a bunch of files?
Yes, it does have a batch mode. So you can process an entire folder. You can put in the specific settings you want for that folder, and it would generate it to whatever output that you want. I probably, if you'd like, I have it here. So here's RMIT.
The last question is this something that you can share with someone that's not NASA?
Yes, this is open.
Sweet, thank you.
So yeah, we have our batch files here. So you can set that. You have your headless mode, which allows you to. Good.
We're still seeing the presentation.
Oh, sorry about that. Let me share my screen instead. Here we go. You see that?
Yes.
Yep. So this is RMIT. You have your headless mode, so you can run everything in the background and set your parameters. Of course, batch file mode, like was just mentioned, and even a headless scripting mode. If you really want to get technical and have things run in particular order, you can do so. Mayor Part Creator, might remember that from Thomas Grubb. And then we have a couple settings, a support form in case anything, any issues come up with logging. And then, you can grab your files. We have a pretty extensive input list because of the utilization of Datasmith. So we do allow a lot of different file formats to be imported. And then we have several export options as well. So this will be the interface that you would use. And then when a model is processed, if it's not in headless mode, you'll basically get the Blender interface. And then you'll get the other control window, which has all the kind of automated functions to run against your models.
Very good, thank you.
Are there any other questions? Okay. All right. Well, thanks, everybody. That was my presentation.
Yeah.
So sorry.
Yeah, just wanted to give you a shout out, you and your team, for the awesome job that RMIT does in model decimation. We developed our own tool that does that. We also evaluated some commercial tools, and RMIT really did a better job. So we plan to use that moving forward. So great job on that.
Thank you. For those that aren't aware, there is a model repository that's being built by the agency that's going to be on the cloud. So it'll be kind of like a service that people can go to. And we're hoping to integrate those RMIT functions into the back end. So that way there's we can expand those file types and processing. So, you have a certain model that's on the web, in the NASA network. You can then get that in several flavors with different parameters set. And then RMIT will handle the back end kind of silently. So that's the next goal.
All right. Well, again, thank you for the presentation. All right. Let's look at the agenda.